Good morning, everybody. I'm Ollie Jones. I'll introduce the company a little bit more in a moment, but most people in this room will already be very familiar with the open ISA story, so I'm not going to cover that at all. But what I do want to focus on is where we see RISC-V landing in real SoC programs, from hyperscale AI and networking down to edge AI and embedded control, and what that means for customization, heterogeneous integration, and getting to production silicon. So, a quick word on why Aion has a credible vantage point, I think, on this market. Well, we're headquartered in Europe, London specifically, and so from an EMEA standpoint, there are not many teams out there in the EMEA region with the combination of advanced node exposure and tape-out volume that we do. We have 18 designs at 7 nanometers and below, current programs on TSMC N3, Samsung 2, and Intel 18A, and hundreds of tape-outs as well. And the reason this matters is simple. RISC-V decisions are only valuable if they survive implementation, verification, and bring-up. So let's talk about execution capacity. We have 120 plus very talented engineers across 4 global design centers, spanning architecture, front-end design, design verification, DFT, and physical design. And that gives customers a single team that they can rely on for programs from concept through to implementation without losing continuity. And it also allows us to provide 24/7 support. The markets we've covered are quite broad. So we see themes across data center AI, edge AI, networking, communications, video, and automotive. But we think experience matters the most, especially as nodes get harder. And so we've been doing advanced node designs now for more than 20 years. And nearly 40% of our team has over a decade of advanced node experience. And finally, the foundry relationships that you see in the footer of this let us to operate a true concept to silicon partnership. We're proud to be TSMC DCA partners, Intel VCA alliance partners, and direct with global foundries. And quality and security are built in. They're not an afterthought for us. So for AI infrastructure, automotive, and other sensitive markets, disciplined execution and strong IP protection are table stakes. So that's why we emphasize both engineering rigor and certified quality and information security through ISO 9001, ISO 27001. I'm not going to go through all the logos here. The point of this slide is to show really that our engineering has made it into many shipped products over the years across a wide range of end systems. And increasingly, we're seeing customer programs using RISC-V somewhere in the SoC. So let's move on to the main theme of the talk here. So how are we seeing RISC-V being adopted in the real world? Well, firstly, and this won't come as a surprise to anyone in the room, AI workloads are accelerating the adoption. We're seeing AI accelerators increasingly embed RISC-V cores. We've already seen deployment in hyperscale AI with SoCs from Meta's MTIA and NVIDIA containing RISC-V. And now we see RISC-V standard in hyperscale AI designs expanding into edge AI. Secondly, innovation is driving AI, and customization is not only the key differentiator, but it's enabling the innovation. So customers are selecting RISC-V for its ISA extensibility, and that's enabling sector and domain-specific custom instructions. And that's allowing optimized pipelines for AI, networking, and embedded workloads. The third pattern is around heterogeneous integration. In most real products, RISC-V sits beside an ARM or an x86 as a function-specific CPU for control orchestration and offload. So for most teams, this is not an either-or decision. The best of both can be utilized. And in practice, that lowers migration risk while still opening up differentiation. Finally, volume started at the edge, and value is moving upwards. So adoption began in MCUs and embedded systems, then expanded into edge AI, networking, and data center silicon. And we've seen this as the ecosystem has matured. And that's why we increasingly see RISC-V becoming the default control and customization compute inside heterogeneous SoCs. This chart from SHD Group shows the bigger backdrop. Electronic systems of all architecture types keep growing, and by the 2040s, the forecast reaches roughly 120 billion systems per year. Every one of those devices still needs silicon architected, verified, implemented, and taped out. So the ARM analogy is deliberate here. Once an architecture crosses a threshold, the ecosystem around it becomes self-reinforcing. That's the phase that RISC-V is entering. There's a new market report from the SHD Group, the 2026 RISC-V report, and that data suggests that the market is moving faster than most earlier models assumed. The first headline is that SoC revenue at nearly $320 billion by 2031. The RISC-V SoC opportunity is large enough that this has been treated as a mainstream architecture option now. The second headline is units. Tens of billions of shipments by 2031, 36 billion estimated shipments of RISC-V units by 2031. And that matters because it tells us that this is not confined to a handful of high-profile designs. The installed base is broad, and that the breadth is what sustains the ecosystem. The third headline is CPU IP revenue approaching $2 billion by 2031. And it's an important signal because a durable architecture needs a real commercial layer around it: IP, tooling, software enablement, etc. And one of the numbers that I'm most interested in is the number of design starts, because that indicates funded intent and not just commentary. So put together, these numbers imply that the RISC-V market is reaching roughly a third of the total SoC market by 2031, which is well ahead of where most people placed it only a few years ago. From there, the question is where those design starts are actually showing up across the market. So let's go into that in a bit more detail. So at the bottom of the chart here, you see MCU. At the MCU end, RISC-V is the unit volume engine. If we move up to the edge, we get a large number of design starts, strategy growth, as inference shifts into automotive, industrial, and other consumer devices. In networking, RISC-V works well as a coprocessor inside heterogeneous SoCs, where throughput, power, and custom packet handling matter. And at the data center end, AI accelerators and adjacent host-side compute are now major revenue opportunities, as we've seen in some of the previous presentations. As a result of all of this, RISC-V and AI accelerators are forecast as the #2 device type by revenue by 2031. And at Aion, we are seeing more and more data center AI accelerators using RISC-V. And again, no surprise, if we compress the story into one force, it's AI, right? So AI workloads reward extensibility. The extensible ISA allows domain-specific custom extensions, making RISC-V an ideal foundation for AI accelerators and neural network engines. We're seeing inference now moving to the edge, and this is expanding the RISC-V adoption further. We're seeing that across PCs, smartphones, automotive, IoT, et cetera, et cetera. We're also seeing that AI is now improving semiconductor designs, workflows themselves. We're seeing AI being integrated into EDA tool chains for RISC-V designs, improving design productivity and automation. And public signals from companies like NVIDIA have made it clear that this has crossed from early adoption into mainstream planning. At the 2024 RISC-V International Summit, NVIDIA announced that RISC-V CPUs would be in all of their SoCs. So we recently gave a webinar hosted by SemiWiki together with Andy's, where we talked about how Aion architects SoCs. I asked my engineers to try and get this onto one slide, so I'll do my best to present this, and I hope I do it justice and to the standard that my engineers would expect. So please bear with me on that. There are 4 principles summarized here, and if you're interested in further detail, I'd encourage you to drop by our booth, which is just outside the door here, or watch the webinar that's available on our website. What we think differentiates us is our architecture-first approach, and with that comes very fine attention to architecture. At Aion, we don't start with the instruction set and work outward. We start with the workload and define the KPI envelope before we map the options onto a scalable SoC framework. And then we generate a cycle-based system C model so we can see where the measured outputs in terms of memory, contention, locality, and performance headroom really sit before we get to RTL. Only then do we decide how much RISC-V customization is worth carrying into silicon. In practice, as we observed earlier, RISC-V is working especially well as control and orchestration compute inside heterogeneous AI SoCs and as a targeted customization vehicle. Conversely, where teams need to pay attention and watch out is software and toolchain readiness. The verification ripple from ISA changes and the fact that the memory fabric is often the first bottleneck rather than the core itself. Kobe, our previous speaker, spoke a lot about the ecosystem, and what we see is that the ecosystem is maturing. A key part of the SoC architecture are the other IP components that make up the chip. And as an SoC design company, we work with a broad range of IP partners, many of which are here today and who are putting more and more attention onto RISC-V. As well as our webinar with Andy's, we've also completed a webinar with Arteris as well, exploring RISC-V architectures. And so we really are seeing the ecosystem developing, collaborations are continuing to develop within that ecosystem. Before I finish, we wanted to ground the numbers, some of the numbers that were presented here in this talk. And working together with the SHD group, we're making a free version of the 2026 SHD RISC-V market report and ecosystem guide available to attendees. It includes market sizing, segment breakdowns, forecast tables, and a vendor and ecosystem guide over 150 plus pages. So please scan the QR code if you'd like to pick up a copy, or visit either the SHD group booth, which is just outside, or the Aion booth, and we can help you with the underlying data behind the report. So I'll close by saying the question is no longer whether RISC-V is viable. It's now mainstream. The question is where it creates leverage in your SoC and how best to capture that value. Thank you.